According to the National Electrical Code, specifically Section 250.52a under 6, you are required to bond certain electrodes to the grounding electrode system. These electrodes include the metal underground water pipe, the metal frame of the building, the concrete encased electrode, the ground ring, the ground rod, and the plate electrode. Furthermore, NEC Section 250.53 specifies that the grounding electrode system must be interconnected where necessary. This interconnection ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed on it. So, even if a ground rod is present as your electrode, you are still required to bond the building steel and water pipe within 5 feet of the entrance to the building. The ground rod, in this case, serves as one electrode for grounding. The building steel and water pipe, being present within 5 feet of the building entrance, are considered potential electrodes. To ensure electrical continuity and safety, the National Electrical Code mandates the bonding of all available electrodes. This requirement applies even if a ground rod is already present. The purpose of this bonding is to create a low impedance path for fault current. By connecting all available electrodes, you minimize the potential difference between different conductive parts of the building. This reduces the risk of electric shock and equipment damage during a fault. Consider a scenario where a fault occurs in the electrical system. The fault current will seek the path of least resistance back to the source. If the building steel and water pipe are not bonded to the grounding electrode system, they may become energized during the fault. This could create a dangerous situation for anyone who comes into contact with them. However, if the building steel and water pipe are properly bonded, the fault current will be safely conducted back to the source through the grounding electrode system. This will help to clear the fault quickly and minimize the risk of electric shock. The requirement to bond all available electrodes is a fundamental principle of electrical safety. It is essential to comply with this requirement to protect people and property from the hazards of electricity. Failure to properly bond the grounding electrode system can have serious consequences. It can increase the risk of electric shock, equipment damage, and fire. Therefore, it is crucial to ensure that all available electrodes are properly bonded in accordance with the National Electrical Code. When installing or modifying an electrical system, it is always recommended to consult with a qualified electrician. A qualified electrician can ensure that the installation meets all applicable codes and standards. They can also provide guidance on the proper bonding of the grounding electrode system. Firstly, the metal underground water pipe must be bonded. Secondly, the metal frame of the building must be bonded. Thirdly, the concrete encased electrode must be bonded. Fourthly, the ground ring must be bonded. Fifthly, the ground rod must be bonded. And sixthly, the plate electrode must be bonded. These are the electrodes that are listed in NEC Section 250.52a under 6 as needing to be bonded to the grounding electrode system. It's important to remember that the purpose of the grounding electrode system is to provide a low impedance path for fault current. This helps to protect people and equipment from electrical shock and damage. By bonding all available electrodes, you create a more effective grounding system. This reduces the risk of electrical hazards and improves the overall safety of the electrical system. Always follow the National Electrical Code and consult with a qualified electrician to ensure that your electrical system is properly grounded and bonded. This will help to protect you, your family, and your property from the dangers of electricity. In addition to the electrodes mentioned earlier, other metal components may also need to be bonded to the grounding electrode system. These components include metal conduits, metal enclosures, and metal equipment frames. The specific requirements for bonding these components are outlined in the National Electrical Code. It is important to carefully review the code and consult with a qualified electrician to ensure that all metal components are properly bonded. When bonding metal components, it is essential to use the correct bonding methods and materials. The bonding conductors must be sized appropriately to carry the available fault current. The bonding connections must be made securely and reliably. Improper bonding can compromise the effectiveness of the grounding electrode system and increase the risk of electrical hazards. One of the most common mistakes made when installing grounding electrode systems is failing to properly bond all available electrodes. This can happen for a variety of reasons. Sometimes, electricians may not be aware of the requirement to bond all electrodes. Other times, they may simply overlook certain electrodes. It is important to be diligent in identifying all available electrodes and ensuring that they are properly bonded. Another common mistake is using the wrong bonding methods or materials. For example, using undersized bonding conductors or making loose connections can compromise the effectiveness of the grounding electrode system. It is essential to use the correct bonding methods and materials as specified in the National Electrical Code. Proper grounding and bonding are essential for electrical safety. By following the requirements of the National Electrical Code and consulting with a qualified electrician, you can ensure that your electrical system is safe and reliable. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Grounding and bonding are two distinct but related concepts in electrical systems. Grounding refers to connecting the electrical system to the earth. Bonding refers to connecting different conductive parts of the electrical system together. Both grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source. Bonding ensures that all conductive parts of the electrical system are at the same potential. This reduces the risk of electric shock. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to protect people and property from the hazards of electricity. When designing or installing an electrical system, it is important to carefully review the National Electrical Code and consult with a qualified electrician. This will help to ensure that the system meets all applicable codes and standards. In addition to the requirements of the National Electrical Code, local codes and regulations may also apply. It is important to check with the local authorities to determine the specific requirements for grounding and bonding in your area. Grounding and bonding are critical components of a safe and reliable electrical system. By understanding the principles of grounding and bonding and following the requirements of the National Electrical Code, you can help to protect people and property from the hazards of electricity. Remember, it is always best to consult with a qualified electrician when working with electricity. They can provide expert guidance and ensure that your electrical system is properly grounded and bonded. The ground rod, building steel, and water pipe all contribute to a comprehensive grounding system. The ground rod provides a direct connection to the earth. The building steel provides a large conductive surface area. The water pipe provides a connection to the water distribution system, which is typically grounded. By bonding all of these elements together, you create a more robust and effective grounding system. This helps to ensure that fault current is safely conducted back to the source, minimizing the risk of electrical hazards. The National Electrical Code recognizes the importance of bonding all available electrodes. That's why it requires the bonding of the metal underground water pipe, the metal frame of the building, the concrete encased electrode, the ground ring, the ground rod, and the plate electrode. By complying with these requirements, you can help to create a safer electrical environment. Electrical safety is a shared responsibility. Everyone who works with electricity, from homeowners to electricians, has a role to play in preventing electrical accidents. By following the principles of grounding and bonding, and by taking all necessary precautions, we can help to protect ourselves and others from the hazards of electricity. Remember to always turn off the power before working on any electrical equipment. Use insulated tools and equipment. Wear appropriate personal protective equipment. And if you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity is a powerful force, and it should be treated with respect. By following these safety tips, you can help to prevent electrical accidents and injuries. The National Electrical Code is a comprehensive set of standards for electrical safety. It is updated every 3 years to reflect the latest technological advancements and safety practices. It is important to stay up to date on the latest version of the National Electrical Code to ensure that your electrical system meets all applicable codes and standards. The National Electrical Code is available for purchase from the National Fire Protection Association. You can also find information about the National Electrical Code on the NFPA website. In addition to the National Electrical Code, other standards and guidelines may also apply to your electrical system. These standards and guidelines may be developed by organizations such as the Institute of Electrical and Electronics Engineers, the American National Standards Institute, and Underwriters Laboratories. It is important to be familiar with all applicable standards and guidelines to ensure that your electrical system is safe and compliant. Grounding and bonding are essential for protecting electronic equipment from damage. Electronic equipment is particularly susceptible to damage from voltage surges and other electrical disturbances. Proper grounding and bonding can help to minimize the risk of damage to electronic equipment. When grounding and bonding electronic equipment, it is important to follow the manufacturer's recommendations. The manufacturer's recommendations will provide specific guidance on how to properly ground and bond the equipment. In addition to the manufacturer's recommendations, the National Electrical Code also provides requirements for grounding and bonding electronic equipment. It is important to comply with all applicable codes and standards to ensure that the equipment is properly protected. Surge protective devices can also be used to protect electronic equipment from damage. Surge protective devices are designed to divert voltage surges away from the equipment. Surge protective devices should be installed in accordance with the manufacturer's instructions and the National Electrical Code. Regular maintenance is essential for ensuring the continued effectiveness of the grounding and bonding system. The grounding and bonding system should be inspected regularly for any signs of damage or corrosion. Any damaged or corroded component should be replaced immediately. The grounding and bonding connections should also be checked periodically to ensure that they are still tight and secure. Loose or corroded connections can compromise the effectiveness of the grounding and bonding system. If you are not comfortable performing maintenance on the grounding and bonding system, it is best to hire a qualified electrician to do the work for you. They can properly inspect the system and make any necessary repairs or replacements. Proper grounding and bonding are essential for electrical safety and equipment protection. By following the guidelines outlined in this discussion and consulting with a qualified electrician, you can ensure that your electrical system is safe, reliable, and compliant. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In summary, regardless of the presence of a ground rod, always bond building steel and water pipes within 5 feet to meet NEC standards and ensure safety.